All right, thank you, Bill. Hello, everyone. Good morning, good afternoon, depending on where you are. Today's presentation is going to be discussing indoor mapping for emergency response and discussing some of the considerations around this topic and some of the overlap that we have in kind of talking about this topic, because indoor mapping was developed around more campus facilities or industrial uses first, and we're recognizing its usefulness and how integral it can be for emergency response. So we're kind of applying some of the technology improvements that have been developed for industry and applying that into the 911 space. So the overview of today is really to discuss address points and emergency data sets in general, kind of reviewing a topic that I discussed last year, and sussing out the differences between sub-addressing and indoor GIS. They're similar, but a little different. Key distinctions between those two things. Then we'll discuss what ArcGIS indoors is versus indoor mapping, and discuss that topic a little bit more in detail throughout the rest of this presentation. I'll try to keep it at a half an hour. Sometimes I struggle with that, but we'll see where we go. All right. So first things first, let's review what address points mean in your GIS data set, specifically for emergency management mapping or emergency response. So your address point data came from somewhere. There are probably multiple iterations of data population that have happened within your 911 data set throughout the years. More often than not, the core of your address point data was sourced from parcel information. This is useful. However, there are some limitations with parcel information, specifically if you have multiple addresses on one piece of land, one parcel site. One parcel address is associated with that parcel. If you have more addresses, then those may not actually be reflected in your GIS data. So there could be additional review needed. So these are the main qualifications on placement methodologies that are used in just populating address point data in general. And this is the core of what address point data is in emergency response data sets. So moving on, this is just a rapid fire review. This is the NENA required attribute data set, attribute fields for your address point layer. You can see here that we have, the major fields that you would expect, like street names, street suffixes, ESNs, community names, yada, yada, yada. But what we're going to be focusing on for sub-addressing and this indoor mapping are these fields over on the right-hand side, starting with our building and going to additional location, landmark names, but really these first six. Address point standards is important to note that while an address point layer is required by any state that's instituting the NG9 9-1-1 data standard, there is no specific requirement on that data set's completeness. Reality is vast and complex, and our GIS data sets are always a simplification of what reality is, and we just try to, it's a continual work in progress to make our GIS data sets as accurate as possible to what the data is on the ground. That process takes a lot of time and resources to develop a full, complete and accurate address point data set. And NENA recognizes that time and resource requirement for a complete and accurate data set is a large ask. So that's why there's no specific requirement on completeness. They're relying on local entities to decide what like where the most important data is, and kind of how to align their data set to get the best use out of their time and resources. So sub-address fields, like I was saying before, specifically refer to this building, floor, unit, room, seat, and a different additional location information. These are optional. They're not required, but they are useful to provide first responders more information, more site-specific information on where they're responding. So instead of just having, say, one address point for a high school that may encompass multiple building sites or football fields, softball fields, yada yada yada. That's the second time I said yada yada yada. I'll try to stop that. Having this information filled out within your data, or having multiple address points with this information associated with it, will help direct first responders to those specific sites that may be on a larger campus. So sub-addressing here is an example, or a few examples from specific instances. So we may have mobile home parks over in the upper left-hand corner that may have one address associated with that mobile home park, but each home may have a lot number associated with it. It's useful to use the sub-addressing information to distinguish what building, what lot the response is needed at. Going down to the lower left, we can see, tennis courts, ball fields highlighted here. And you can note that these are all address point specific entities. They're just point files, essentially, with additional information associated with them. Where we start getting into the fuzzy blend of sub-addressing and indoor mapping is on the right-hand side, where sub-addressing is used for room information. There are different methodologies and response preferences that are dependent upon particular agencies and CAD softwares that which one is more useful. So in the upper right, we have the units being displayed within each room, whereas in the bottom right, you have the unit access points displayed at the door entry. Again, this is sub-addressing, so this is all represented in the address point layer. So what type of places could this be useful in? This is, again, just a review from my last or a previous talk. We have a lot of multi-point place types that could be that could utilize sub-addressing information. You can see a list of them here. But I ended my last presentation talking about the future of address accuracy. And this is coming from NENA again, that in some areas, a three-dimensional environment, we're placing individual points to represent sub-addresses at elevation may be valuable and needed. That's what we're talking about now in our expansion into Indoor GIS. So not only do we have sub-address information that is located at address point specific data, now we're able to kind of expand that information to include facility maps. So we're talking about building outlines, hallways, doorways, as well as other pertinent data like key access points, defibrillators, extinguishers, all of that additional data that may be useful for responders. It should be noted that while both sub-address points and indoor data allow verification or location of an address, the additional information of what that building looks like on the inside is really is the advantage of Indoor GIS. So while we can do sub-addressing for, say, a school, those are just points on a building, and they're points that are estimated at where the room may be located in the building without actually having the facility map displayed on the data. So the future is now, like I was saying, we're expanding into the indoor GIS space. States are seeing the advantages of indoor GIS, and multiple state governments are moving forward with providing the means of collecting this data. So the current focus from multiple states is to improve K through 12 facility data sets to kind of bolster response for those facilities. That being said, like that long list of multi-point address types are still accurate and viable, but the financial grants focus around K through 12 facilities at the moment. It should be noted that in order to do this work, it really requires school stakeholder support, participation, awareness. We need, if you're going to be collecting data on these schools, you need to have school administrators aware of what's going on and why it's happening to produce the best data set possible. So indoor GIS maps allow for dispatch and responders to see the same highly detailed and accurate information of a building or facility or campus. The address data, like the GIS data itself, can be updated if it's maintained regularly to keep that map accurate and relevant. So with schools, we all know that schools are in change. They change often as far as new facilities, or a room rearrangement, or a wall is taken out or walls put in. Once you get that GIS data of the building itself set, then any small changes or fluctuations in how the layout of the building is concerned is easily maintained within the GIS. That GIS data then can be used to produce maps with symbology configured to an agency's preference. And it just allows a lot more buy-in from the agency to see what's happening in a building in real time. So we'll discuss what is ArcGIS indoors versus what is indoor mapping. It's a difference, but they're related. ArcGIS indoors is specifically an Esri or ESRI Esri product. It's a collection of tools that streamline the process of importing LiDAR, CAD, and BIM data into a GIS configuration and deploy a robust interactive solution through web or mobile devices. So the simple explanation is ArcGIS indoors is the method and the means to produce indoor GIS products. So indoor GIS, I guess, is a bit more of a broader terminology, whereas ArcGIS indoors is the means to produce those things. So to make an indoor GIS data set through ArcGIS indoors, these are the technical requirements. This is what we at CloudPoint will use to produce the data for our clients. We use ArcPro here, and we can produce multiple different outputs with that data. So the big question here is, if you're interested in getting your facility mapped and your facility to produce a GIS indoors output data set, how is that done? It's floor plan data is the main thing that we're using, and it really depends on each location, each building, because we can use georeferenced, digitized, as-built documents. That's specifically different than, you know, original architectural design. As-built are, you know, products of the actual building that might be different than what the original design was. So it's important to make that distinction that we're wanting to map the building as is, not the building that was designed, because there can be differences there. Sometimes those as-built documents are unavailable or lost or don't exist at all, in which case there might be CAD data, computer. In this case, I know we're in you know, the public safety, this is a public safety webinar, so the CAD that I'm referring to here is computer aided design, and that's building layouts, usually within a DWG file. We can take that and import it into a GIS data set. We can also use the BIM data, and that stands for Building Information Management. We can import from there. But honestly, the most accurate way of producing indoor GIS data sets is through terrestrial scanning, and that's LiDAR scanning specifically, using lasers to measure very precisely where things are in the building and map the actual environment in place. There are multiple ways of doing this, and we'll talk about that in the next slide. For now, I want to talk about in general, because we're talking about campuses as well as buildings, we use multiple different ways of collecting this data. Specifically, when we're talking about campuses and outside facilities, it's good to use accurate and recent as possible aerial imagery to know what a larger campus looks like, where you know, ball fields or buildings themselves lay within a campus. We can do that through drone flights or through recent aerial imagery, aerial orthophotography. And often this data is available through either city or county GIS departments. The key thing is to look for digital data first. Hard copy, you know, printed data is definitely is not preferred, but it's still viable if that's what you have available. Again, if you can't find it, then scanning for this data is the best way of doing it, collecting it. Now moving into zooming in from a campus area into a building itself. LiDAR scanning, like I said, is the preferred way of getting the most accurate data. You can use different ways of collecting LiDAR data. Handheld 2D devices or 3D room scanning LiDAR data devices are available. And even using a mobile app-based collection device is feasible. How the data is collected, it really impacts its accuracy and fidelity. Getting those handheld high caliber LiDAR devices or 3D room scanning devices in the building itself is going to produce the highest quality image and data that we're collecting, and that's going to produce obviously the highest fidelity output. Let's see, the mobile device is an expanding space. It's still developing. It's you know, we're in technology, everything's fluid and developing. So at the moment, it's not as I would say it's not as preferable as having, you know, actual LiDAR equipment in the building itself to collect the data. But you know, give it a few years, we'll see what happens. It may become increasingly impressive. So the setup for indoors is, this is kind of the methodology that we use whenever we're conducting an indoors project, regardless of it being for campus facilities team or for public safety. We're going to base our data set off of the ArcGIS indoors informational model. It's very similar to, it has a lot of the requirements that the NENA schema has. It's a bit more elaborate and based on those industry standards. So it's highly specific for indoors. So it may go beyond the needs of what an emergency management or emergency response data set may require, but it's going to provide even more information to be used. Then we'll have map templates to build your buildings off of. We'll populate the attributes. So how many floors are there? What are the room names, their numbers? Where are the specific pertinent information? So where are those security cameras, fire extinguishers, defibrillators, etc. We can do pathways, and we'll talk about that in a few more slides. Finally, after we collect that data and organize it and build it out, then we can publish that data into map products. And finally, have engagement with users where those map products are viewed either by response entities, dispatch entities, or management. All right, so let's talk about kind of looking at how indoor GIS is useful in different ways. And this is where this main slide here, the building locations, really touches on the biggest advantage and the most useful aspect of indoors GIS for emergency management, public safety. I'll have a few more slides on additional capabilities and options that are useful and maybe something of interest to your agency, but not necessarily, a requirement. So building locations, knowing where a building is, where the rooms are in that building, being able to search within the building at where those rooms are, knowing where the doorways and the entrance and exits are to a particular room are all very valuable information for our first responders. Additional capabilities. So we have mobile editing options. So we can set up an ArcGIS collector app that will allow us to gather more information on a particular building and allow a verified user to make edits to the GIS data set via mobile devices, which is really useful. Oh, no, it's loaded. So this will essentially allow if there's a new feature, say a fire extinguisher was moved, or there's a new fire extinguisher added to a room, instead of having to contract for someone coming in and putting that point down or taking a picture and sending it over with information associated where that fire extinguisher is located. You can do a mobile editing option where you can open up the app and input that feature in its location just via your mobile device. We can do mobile reporting utilizing Survey 123, allowing for reporting workflows to happen. So if we notice that there's an issue or something that needs to be changed, the Survey 123 app will allow you to produce a report and submit that for a data edit request or other requests that may come and become necessary. ArcGIS Indoors Mobile. So this is just the output. So we can take our indoor GIS data set and package it. And this MP or MMPK file allows us to share this indoor GIS data through Enterprise Portal or through ArcGIS Online accounts, which helps the data's accessibility to multiple user types, whether you're on your local computer or using it on a mobile device. And again, this is additional capabilities, but if we build out routing within the data, you can have essentially, like a Google Maps direction. It's not really Google Maps, obviously, this is internal, but you would get walking directions instead of driving directions from one place to another place using the mapped most efficient walking path. Also, we can have real-time locating systems. So this uses Wi-Fi, Bluetooth, and other beacons to know where you're located within a building. So this is sometimes within large buildings, you may not have the greatest cell phone reception. And that's just how, wireless cell towers work, and how the frequencies sometimes are repelled by large building structures and thick walls. So having some of these other devices embedded within the building allow for essentially internal GPS to be used inside a large building. So this is just I'm wrapping up here, but I wanted to make note of what it means to be floor aware. Floor aware is a terminology that you'll hear within the space, and essentially just means that we're able to organize indoor data sets by floor. There's a floor field within the NENA required field types, which is nice. You can tell like what room is on which floor. This is just an expanded version of that. So instead of only having floor sorting capabilities for a room, here we can organize our data, the whole building data set by floor. So we can see what rooms, what features are on each floor, which just allows the response to see complex overlapping data in a more simplified, streamlined fashion. So for instance, this is an example of that. We're on the second floor of this building here. That's a six level structure, but we're only displaying the rooms that are on the second floor instead of having to peer through all 6 levels simultaneously. So floor aware is very useful as far as sorting and displaying information. Some additional resources as I kind of bring this to a close. I encourage you to check out the Esri web map or website. There are a lot of additional indoor webinars and resources out there. This is an emerging space for public safety, but it's well trodden in other sectors of the GIS industry. So public safety is kind of coming into is gaining the benefit of previous trial and error in other sectors. So we're able to kind of come at this with a clarified vision on providing the data that is necessary for our first responders.